Question 9, we've been told that Lunet's tent is in the shape of a triangular prism. The cross-section of her tent is an isosceles triangle, and she noted a few measurements on the diagram. Calculate the volume of Lunet's tent, give your answer in cubic meters, and we must show all our work in. So, for volume of prisms like this, we need to get the area of this cross-section and times it by how far back it goes. Well, obviously at the moment we got a triangle, so we got the base, we know that's 0.7 and that's 0.7, we'd have 1.4, but we need the height. So we need to find this height, so we're going to have to use Pythagoras to quickly find this height. So we know Pythagoras, h squared is a squared plus b squared, or you might know it in a different version with a's, b's and c's, but we should be able to follow this. We've got the hypotenuse of 1.8. We've got, we call the height x for a moment, and we know the b is 0.7 squared. So rearranging this, we know that it's 1.8 squared take away 0.7 squared, and then we're going to find the root of that answer. So 1.8 squared take away 0.7 squared, so it's going to be x is going to be the root of 2.75. root answer, we get 1.6583 ... So just for the use in calculations, perhaps it's because we're going to use this somewhere else, this maybe just round to 2 decimal places, 1.66 meters tall. So now we have that, we can work out the volume. So if we get the volume, we first of all work out the area of this face of the triangle. So I know it's going to be the base times height divided by 2. So the base is 0.7 plus 0.7. So 1.4 times the height of 1.66, or whatever your answer was for part A. Divide that by 2. And whatever the answer is to that, that's the area. We're going to times it by the length of that prism. So times by 2.5. And that should give us, so that times 1.4 divided by 2 times by 2.5, we should get an answer of 2.902 ... So again, rounding it, we should say that's going to be 2.9, O if you want to go to 2 decimal places just to be consistent, and it's cubic meters as well. So 2.9 or 2.90, or any answers between 2.9 to 2.98 would be acceptable. Even 3 meters would be, or 3 cubic meters would be acceptable if your workings beforehand was accurate. For part B, which of the following is equal to 0.2 cubic meters? And we need to convert it to centimeters cubed. So again, when dealing with conversions with volumes like this, the easiest way to think about it, I believe, is to think, well, if all the units of this, I've drawn a little cube here to help us see it. If we were to convert the length, the width and height from meters to centimeters, well, I would need to times this by 100. I would times this length by 100, and I would times this length by 100. So that's effectively what you're doing to 0.2. So if you work out 0.2 times 100 times 100 times 100, we should get 200,000 cubic centimeters.